Hi guys, so today we're going to look at the sum and different identities for both sine and cosine. So here are the formulas, and you don't have to memorize these. We'll give you these when you need them. But if you look at them, we want you to see the patterns. Notice when it's the sine and it's a sum, it alternates sine, cosine, cosine, sine, and it keeps the addition. Sine of a difference, it alternates sine, cosine, keeps subtraction, cosine, sine. But if you look at the cosine functions, cosine of the sum, it's cosine of the first, cosine of the second, and it changes the sign now to subtraction, then it's sine A, sine B. Cosine of the difference, it's cosine of the first, cosine of the second, change subtraction to addition, sine of the first, sine of the second. So those are the patterns I want you to be aware of. The other thing I need you to do, if you don't already have your special angle values memorized, that the sine, cosine, and tangent of all your special angles, you need to pause the video right now, go find your chart or wherever you have that information, or write it down so you have it to refer to, because if you don't know your special angles, you're not going to be able to do the problems that we have chosen for you. Okay, so you need to do that. And I'm going to be very honest with you here also. At this level, the algebra to trigonometry level, these identities were more useful before we had calculators. Now that we have the calculators, they're not quite as necessary until you get into more advanced mathematics. My calculus students use these identities to make functions easier to differentiate or integrate. They use these identities to help prove or develop new rules. So they do need to know these identities in upper level, in further math classes beyond this point. But the problems that we're going to look at today, it's really just to get you used to the format of the identities and how they're used. Okay, so what the patterns are is really more what we're looking at. So here we are. We're going to use the angle sum identity to find the exact value. Now what we need to do, the first thing we need to do, now notice this is sine, so we're going to be using this identity, the sine one. We need to find two angles, and they should be special angles or angles whose reference angles are special angles. So we need two angles that add to 195. Now remember, your special angles are 30 degrees, 45 degrees, and 60 degrees. So let's think, if we use 45 degrees, 195 minus 45, that would be 150 degrees, right? Well, now you're looking at me going, but that's not a special angle. 150 degrees isn't a special angle. But if you think about 150 degrees, it's in the second quadrant. And how far away from the x-axis is it? 180 minus 150 is 30 degrees. That reference angle is a special angle. So we can use this. Now when we use this, this is the A and this is the B, the first and the second angle. So the rule that we have for sine is to take the sine of the first angle times the cosine of the second angle, keep the addition, cosine of the first angle, sine of the second angle. Now you need to know your values. Now, sine of 150 degrees. 150 degrees is in the second quadrant, and we know that all students take calculus. Sine is positive there, and the reference angle is 30 degrees. So we can rewrite this as the sine of 30 degrees. Now the cosine of 150 degrees, cosine of 150, cosine is negative in the second quadrant, and the reference angle is still 30 degrees. Now let's find our values. The sine of 30 degrees is 1/2. The cosine of 45 degrees is radical 2 over 2, minus the cosine of 30 degrees is radical 3 over 2, and the sine of 45 degrees is radical 2 over 2. Those values came right off of my chart. I have them memorized, okay? We multiply. 1/2 times radical 2 over 2 is the square root of 2 over 4. Minus radical 3 times radical 2 is radical 6 over 2 times 2 is 4. We have the same denominator, so we subtract the top, radical 2 minus radical 6, all over 4. That is as simple as our answer can get. So that is what sine of 195 degrees would be in exact form. That's the exact value. Let's try another one. Let's do the cosine of 195 degrees. Now, I purposely picked one. It's the same angle, so we don't have to think too hard. We're going to use the same angles. The cosine of 150 degrees plus 45 degrees. Only this time, we're going to use this identity. So this is my A is 150 and B is still 45 degrees. So now when we follow the pattern for cosine, that would be the cosine of the first, which is 150 degrees, the cosine of the second, which is 45 degrees, minus the sine of the first, which is 150 degrees, times the sine of the second, which is 45 degrees. Now, if we look at this cosine of 150 degrees, 150 degrees is still in the second quadrant. Cosine is negative in the second quadrant. And our reference angle for 150 degrees is still 30 degrees. Then we have the cosine of 45 degrees minus, and if we look at this sine of 150 degrees, because 150 is not a special angle, it's in the second quadrant, which means sine is positive, and the reference angle is 30 degrees. Then we bring along our sine of 45 degrees. Now it's time to find our values. So it's the negation of cosine of 30 degrees is radical 3 over 2 times cosine of 45 degrees is radical 2 over 2 minus the sine of 30 degrees is 1/2. The sine of 45 degrees is radical 2 over 2. Right off my chart. Okay, multiply. Negative radical 3 times radical 2 is negative radical 6 over 2 times 2 is 4. Minus 1 times radical 2 is radical 2 over 2 times 2 is 4. We have the same denominator, so it's negative radical 6 minus radical 2 all over 4. This is our special value. Okay, that's all there is to it. Now, let's look at the angle difference identity. So now we're looking to subtract two angles, and I'm going to put parentheses there. When there's a negative angle, we should have parentheses around that. So we need two angles, preferably special angles, that will subtract to give me negative 15. Now I know 45 minus 30, those are both special angles. 45 minus 30 is positive 15. So if I reverse it and say the cosine of 30 degrees minus 45 degrees, that will give me negative 15. So this is my A minus my B, and we're looking at cosine of the difference. So we're going to follow that pattern. So we have cosine of the first, which is 30 degrees, cosine of the second, which is 45 degrees, change to addition, sine of the first, which is 30 degrees, times sine of the second, which is 45 degrees. Now, right off our charts, the cosine of 30 degrees is radical 3 over 2. The cosine of 45 degrees is radical 2 over 2. Plus, the sine of 30 degrees is 1/2. The sine of 45 degrees is radical 2 over 2. Multiply. Radical 3 times radical 2 is radical 6 over 2 times 2 is 4. Plus 1 times radical 2 is radical 2 over 2 times 2 is 4. When we add, we get the square root of 6 plus the square root of 2. They're not like radicals, so we can't add them. And we keep the denominator 4. And that's it. Okay? Let's try one more. The last type, we'll do a sign of a difference, just so we've tried one of every type. So this time we have 105 degrees. So we need two angles that'll subtract to 105. Now if it ends in a 5, odds are I'm going to have to use 45 degrees. So 105 plus 45 is 150. So what if I use 150 degrees minus 45 degrees? That will subtract to 105. So this is my angle A, this is my angle B, and we're using the top identity here. So this is going to be, take the sine of the first, 150 degrees, times the cosine of the second, which is 45 degrees. Keep the subtraction. The cosine of the first, 150 degrees, times the sine of the second, 45 degrees. Now, these 150s, they're not special angles, so we want to try to think about those a little bit. 150 degrees is in the second quadrant. Okay. It's got a reference angle of 30 degrees. And sine is positive in the second quadrant with a reference angle of 30 degrees. I'm going to keep my cosine of 45 degrees minus, now this cosine is negative in the second quadrant and the reference angle is still 30 degrees. And we keep the sine of 45 degrees. Now it's our values. The sine of 30 degrees is 1/2. The cosine of 45 degrees is radical 2 over 2. I have two negatives, becomes a positive. Cosine of 30 degrees is radical 3 over 2 times sine of 45 degrees is radical 2 over 2. 1 times radical 2 is radical 2. 2 times 2 is 4. Plus radical 3 times radical 2 is radical 6 over 2 times 2 is 4. And our final answer is the square root of 2 plus the square root of 6 all over 4. And that, my darlings, is it. So the idea is go slowly and follow the pattern in the rules that we give you. All right, guys, have a great night.